This is problem 123 of Neetcode on 50 jump game. So we're going to be given an array of integers, and each entries will represent basically a step. And let's set at this particular step, so let's say at step 1, we have a 1 like here in this example. Well, we're being told that we can jump one step further. So we can go to this step 2. All right, so at this step 2, we have the ability to jump 2 steps further from where we currently are. But this is the maximum because we can actually jump one step further as well. So we are not forced to jump 2 steps ahead. So we can go to this 0 or we can go to this 1. But what if we decide to be energy efficient and spend less effort and just go one step up? Well, we're going to be at a place where we can't go any further. So we are going to be basically cooked from there. But what if we jump 2 steps further? We're going to reach this 1. And at this 1, we can actually jump 1 step further to reach the 0. And the goal is really to start from the first index and reach the last index. So you don't have to reach like something that is out of bound. You need to reach the last index. So whatever the value of the last index is, we don't really care because we don't need to go any further. Even though we reach a 0, we don't need to go elsewhere. So it's fine. So couple ways to solve this problem. I think that the one of the easiest way I can think of is basically to start from the first number and see where it can lead. So now we can basically go to the index 1. And what I will create in this naive approach is basically a hash map. And in a hash map, I'll store every position and I will store a boolean as the value of whether or not we can go to this place. So at the index 0, I know for sure I can go there. I mean, this is the base case. There's absolutely no way that we block you from reaching the index 0. So this is something we know for sure is going to be true. But now from this index 0, we can see that we can reach the index 1. So in the index 1, I will put a true here. Right, and from this index 1, I can see that I can go to index 2 and I can go to index 3. So now we're in a pretty good position. I can go in index 2, I can go to index 3. So I'm just placing the keys of the indexes we can go through and the boolean of whether or not we can there. And then from index from index 2, well, I can go anywhere. Right? I'm blocked, so I can't add anything on the hash map. But at the index 3, I can actually go to the index 4. So now I can add through this index 4. And from this index 4, I can go basically through all the other indexes. So I will just add a through 4, 5, 4, the 6, and the 7, as we have 7 indexes. And at the end, what I can do is that I just do a for loop and I go see every single value of each keys inside my hash map and see if each of them is true. If one of them is false, it must mean that we can't reach the last index. But notice that in the worst case, all these values are super big. So that means that if like all the values are like 500, for example, I'll actually have to go through all the other values right now and see what their current value is in a hash map and set that value to true. So in the worst case, for each values, I go see all the other values. So we know that this is going to have a time complexity of big O of n squared. In the worst case. Can we do better? Yeah, for sure. So we're going to use a greedy approach, and I will teach you how we do this. And it is actually super simple. You'll see. So instead of starting from the beginning, we're going to start from the end. And from the end, we know that we have a target index of 0, 1, 2, 3, 4, 5, 6, 7. So we have to reach the index 7. So this is our target. Okay. But what if like midway we realize that we can actually reach this target? Will that mean that our new target will be this midway index? Because we know that if we reach this from the beginning, we are going to be able to reach the last index. So that will make sense to readjust the target index, right? So what I will do is that I will initially start my target to be the index 7. And now I will go see all the other indexes. So from this 0, I actually can't reach the index 7. From this other 0, well, I'm at the index 5, right? From the index 5, can I reach the index 7? No, because I can move anywhere. But from this index 4, can I go reach the index 7? Yeah, of course. So what what I will do is that I will just update my target to be the index 4. Because now I know that if I am able to reach this target 4, I will also be able to reach the target 7, which is the last index. So I will keep going, and I will go see the index 3. And from the index 3, I can actually go to the index 4. So I will update my target index from 4 to 3, because I know that if I am able to reach the index 3, I will be able to reach the index 7. So we're going to go to the index 2, but from the index 2, I actually can't reach the index 3. But from the index 1, I will be able to reach, with my 2 steps, I will be able to reach the index 3. So now I know that if I am able to reach the index 1, well, I will also be able to reach index 7, right? Pretty wise. And now if I go to the index 0, I can actually reach the target, which is the index 1. So I will update this target to be the index 0. And well, we know that we are for sure going to be able to reach the index 0. So in this case, we will say that the answer is true. So at the end, the target should be equal to 0. So let's code this up. All right, so first thing we want to do is to create a target. This is going to be equal to the len of the nums minus 1. And now I want to go through every numbers in a reverse order, but I don't want to reach I don't want to get the last numbers inside it, because we don't care about these values. Once we are there, there's nowhere else to go. So whatever the value is at this point, we don't care. So I'll say for I in the range of the len of the nums, and I will do this minus 2 because I don't want to reach the last index, and I want to go up to the first index, so index 0, and I want to do this in a reverse order. So basically, if at this current position, so if I plus the nums at the index I, so if this is greater or equal to the target, it must mean that we are going to be able to reach the target. So if this is true, the new target is going to be this current position. Okay, and that's it. So now we can basically return target is equal to 0. So if it happens to be equal to 0, it means that from the index 0, we are going to be able to reach the index that is the last one. So let's test this out, and it works perfectly. And notice that we are not storing anything. So we're gonna have a space complexity of big O of 1, and we're gonna have a time complexity of big O of n, because we're only going once through every single numbers. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.